Hi everyone, this is going to be a short video on dividing with complex numbers. I'll do a couple examples so that you can use them as models if you have problems that you have to do that involve division. The first thing I'm going to put up is a problem that might look like this. 2 plus I divided by 4I. Now, that looks like a regular old fraction. But we have to remember that what's being implied in the denominator is that there's a square root in the denominator. I represents the square root of -1. So this really means the same thing as 2 plus the square root of -1 over 4 times the square root of -1. I don't want to write my problem that way because it looks a little bit complicated. And we like to write the square root of -1 in terms of I, but I wrote it that way so that you recognize that there really is a square root in the denominator. And we learned in Algebra 1 that having a square root in the denominator is not mathematically acceptable as far as presentation goes. So in order to get a square root out of the denominator, we have to do what's called rationalize. And in this case, we're going to rationalize, the denominator by multiplying by, I'll write the problem over again. If there's just one term in the denominator, we can just multiply by the equivalent of 1, which would be I over I. If we multiply I times I, we know we're going to get I squared, and I squared represents -1, which means the radical will disappear from the denominator. So when I do this, this is my rationalizing factor I'm multiplying by. I'm going to take the I in the numerator and distribute it into the original. So this will become 2I plus I squared over, I'm going to multiply 4I times I, and that gives me 4I squared. I want to simplify all my powers of I. We learned that I squared is equal to -1. So this will become in the numerator 2I minus 1. The denominator is going to be 4 times -1, which is -4. So 2I minus 1 divided by -4 is a simplified, properly written, rationalized form of division with complex numbers. So if there's one term in the denominator, like a 4I, nothing being added or subtracted onto it, your rationalizing factor is strictly just I over I. Now, you might see something a little bit more complicated, maybe something like 3 plus I over 2 minus I. So the difference between the first problem I did and this problem is that the denominator has two terms, 2 and the minus I. When we have more than one term, the only way to rationalize this is to multiply by the conjugate of the denominator. So we're going to multiply by the conjugate of the denominator. So my problem is going to look like this now. 3 plus I over 2 minus I is going to get multiplied by 2 plus I, which is the conjugate of the denominator, over 2 plus I. This now has turned into a FOIL-looking problem. Definite FOIL in the numerator because nothing is really the same with opposite signs. So I'm going to do 3 times 2. I'll do it down here, which is 6. That's the first. The outers, 3I, plus 2I, those are the inners. And then I times I for the last gives me I squared. The denominator, because I know they're conjugates, and I should start to try to remember this, conjugates I only have to multiply the first and the last because the middles will always drop out. So we get 4 minus I squared. Again, we want to simplify anything we can by combining like terms or simplifying powers of I. I have like terms, and I have powers of I, which are I squared in this case. So the I squared we know is -1, so this will become -1, and this will become +1 now in the denominator because it's minus -1. We're going to have in the numerator 6 minus 1 is 5. 3I plus 2I is 5I. Over 5. I'm okay right now with you leaving your answer like this. If you want to challenge yourself, you know I can always challenge you to do some factoring. In the numerator, there's a greatest common factor of 5. We can pull that 5 out, and we're going to have a 1 plus I left over. The denominator is a 5. These 5s, because the 5 in the numerator is attached to the 1 plus I by multiplication, can get reduced out. And this will actually end up just equaling 1 plus I. This is kind of the challenge point at this point. You need to definitely get to here for me. So these will be 2 examples that you could use for some of the problems that I give you to do in your dividing with complex numbers problem set. Hopefully they will help.